Okay. Lecture 4.1, pulse width modulation. So pulse width modulation is a technique used to deliver an effective variable signal to a load, in our case a motor, but we're going to be delivering these PWM signals to, without a truly variable power source. A pulse of full source amplitude is repeated at high frequency. For example, 20 kilohertz, so like pretty fast. Or you can do megahertz as well, depending on your hardware. Delivering a signal that is effectively averaged by the load dynamics, such that its effects on the load are nearly continuous, which is nice because, well, we all know this, right? If you put in, a pulse of 1/20,000th of a second long, you don't expect a voltage pulse. You don't expect your motor to necessarily speed up for 200 or 1/20,000th of a second and then stop. Okay, motors kind of like they just react a little slower than that, right? So it might start moving a little bit, but it's not going to just like rocket up in speed and then drop down. And that's mostly because of its inertia, right? So effectively that sort of averages out the pulses that you apply to the motor. And just the dynamics of the motor allow you to... Ooh, somebody's laptop's going to take off?
Yeah.
Yeah.
Just doing its thing right now.
Yeah, task manager, right? Yeah.
It's being used right now. It's a data mining.
Yeah, that's right. Somebody's getting Bitcoin or Litecoin or something. Yeah, you clicked on that link. Yeah. So we have this ability to apply these quick pulses, and as long as we do them quick enough, the behavior of the motor mechanically is going to be sort of smoothed out. And we'll see what is effectively just the average effect of those pulses. The fraction of the period t that the signal is high or on is called the duty cycle. And we often use the Dirac delta or the Greek delta function, not Dirac delta in this case. Figure 4.1 shows a PWM signal and its average with a few parameter definitions. So let's look here. We'll draw in where we think the average is. So voltage on, off, on through time. Okay. So the average of this is going to be, we can see that it's more than half the time it's on, right? So doing just some visual geometry, visual area calculation, I don't know what it is, it's probably geometry. We could say that's probably an average of about that much, right? And if we were to call this peak up here A, then we'll find in a moment that this average is just delta times A, which is the duty cycle times the full amplitude. Duty cycle being W over T, the width of the pulse divided by the period. So we can do that with calculus to be smarter than other people and know that, of course, the average of a signal over a period of its repetition, if it's a periodic signal, is just the integral divided by the period. And we can evaluate that for a PWM signal since it's a square wave, and we love integrating over square waves. We can just get A delta. Shows that if a PWM signal is delivered to a load, such as a DC motor that is relatively unaffected by high-frequency signals, the effective signal will be simply the product of the source amplitude and the duty cycle delta. The duty cycle can have values from 0 to 1, so the effective DC signal produced varies linearly with delta from 0 to A. So you can go full bore on, or you can go off, right? And so you can do this for a voltage-controlled voltage source where you put in a voltage to it and it will produce a voltage with some power behind it on the other side. Or you can have a voltage-controlled current source, which is what we'll be using in Lab 4, or a current-controlled voltage source, or current-controlled, or a voltage-controlled voltage source. All of these are possible. I might have actually repeated the voltage-controlled voltage source. Current-controlled current source. That was the one I didn't say. Yes! It's amazing when you get up in front of people, you can't remember things that you said 2 seconds ago. It's great. Yeah?
I'm getting how to put a variable input without a variable source.
Well, effectively by just putting in your single on input. So say your input's either on or off.
So it's just like.
So you just turn it on for part of a period and then off for the other part of the period. And effectively, if you're driving a load that's inertial, like a motor typically does, then it will operate as if you put in that average value. So we'll get in a little bit of the details of how we do this, but suffice it to say that we can put these signals in, and if you apply these voltages to a motor, as is very common to do, you get essentially continuous operation, and it doesn't appear to be a weird on-off switched driving. Although, there's some nuance to that, so we'll talk about that. But approximately, PWM is amazing, and it's so easy, and all you need is some big dumb voltage source at some big power level, and then some smart little voltage source that can pulse, and then something to mate the two together. And yeah, that's what we'll do in a minute, I think, unless there are mad questions. No? Happy questions.
How was your day?
Oh, my day was great. Thank you for asking. Actually, I didn't sleep well last night, so I'm like, I don't even know what I'm doing at this point.
You can sleep through classes. It's what we all do.
I had a 7:45 meeting this morning, so that's how I started my day. Which meetings aren't my favorite. Meetings before noon are definitely not my favorite. Meetings before 9 are just ridiculous. Meetings before 8 I hadn't even heard of before. And we've got one. I don't know. It happened somehow. I was here. I don't remember what happened, but I was there. I was drinking a lot of coffee. Yeah, I was drinking mad coffee.
When did you go to bed?
That implies that he did go to bed.
I mean,
Not true, I assume.
it was pretty late. I usually get a good night's rest, but last night I'm not a person who stays up worrying about things. But I woke up at like 3 a.m. and just started worrying about things, like the university politics and things I read about in the news yesterday. All kinds of stuff. So yeah, I don't know what happened last night. It was not usual. But I cuddled with my puppy, so it was fine. Pepper. She says that if I'm not sleeping, she's not sleeping. So it's great.